Okay, 7.6, solving exponential and logarithmic equations. Exponential equations are equations in which variable expressions occur as exponents. Okay, below is useful for solving certain exponential equations. If your base is a positive number other than 1, then b to the x and b to the y are equal to each other. If and only if x equals y. Okay? Which means I can start to solve for what the exponent is, or I can start to solve equations, because if I have 3 to the x equals 3 to the 5th, that means x equals 5. I can get rid of the 3's because the bases are the same.
So if the bases are the same, then x automatically equals 1.
And whatever power is up here automatically equals whatever power is up here. Okay, now, here it says, solve this, and it gives you 4 to the x equals 1/2 to the x minus 3. What's my problem with this?
They're not the same base.
Not the same base. Can I get them to the same base?
Yes.
How? How can I get those to the same base? Okay, look at this. This base is 4, this base is 1/2. What do you know about 4 and 1/2? Okay, 2 squared is 4. That's good, so we're going to start there. 2 squared is 4. So I'm going to change this to 2 squared to the x. Can I change 1/2 so it's 2 to some power? What? Not 1. How do I get 1/2 to flip so that it says 2 to some power? Yeah, -1. So you're going to say 2 to the -1 to the x minus 3. Now I have the same base. So if they are not in the same base form, you've got to do some thinking and get them there. Okay? So in this case, 2 squared to the x is the same as 2 to the -1 to the x minus 3. Now, since they're the same base, these bases cancel. What's 2 to the x? And what is -1 to the x minus 3? -x plus 3. Distribute that into both portions. Now from here, can I solve?
Yes.
Yeah, I just add x to both sides, right? Or you get 3x equals 3, so x equals 1. Now watch, I can check my answer because I can say 4 to the first equals 1/2 of 1 minus 3. 4 to the first is 4. What's 1/2 to the -2?
4. Or 2 squared.
Yeah,
So
because
that's
you
4.
flip it, right? So I flip it so that it says 2 squared, so it's 4 equals 4. So my solution was x equals 1. Okay? The bases have to be the same. If the bases are not the same, you can't do anything. You've got to get it to the same base. Okay, with that being said, here I have 4 to the x equals 11. Now, are the bases the same? No. Can you get them to the same base? No. That's when you use logarithmic functions. Okay? We're going to focus on whatever side has the x with it, the exponent. Okay? That's the 4 with the x. How can I get rid of a number, like if it says 7 squared, and I want to get rid of this 7. How do you get rid of that? No. No. It's something we've been doing this chapter. What? What cancel, what do you have to do? You're on the right track, say that. Okay, so you have to use log, because natural log goes with what?
E.
E. This isn't an E, this is a number. So if I want to cancel that, I would say log base 7 of 7 squared, and this cancels, yes? So how am I going to cancel 4?
Log base 4, 4x.
Yes. I'm going to say log base 4 of 4x. Now, here's the deal. Whatever you do to one side, you have to do to the other side. Okay? So I added log base 4, so I'm going to add log base 4 of 11 here, okay? This cancels, giving me x equals log base 4 of 11. How do I solve that? We learned it yesterday. How can I solve it? Because in order to solve it, you have to be able to plug it into your calculator. So what do you have to do? What's that called? What do we have to do?
You have to change it into exponential.
Well, you said change. What's that thing we learned yesterday? Change of,
Base.
okay, how do I change the base to do that? What base do you have to use in your calculator? 10. Okay, how do I set that up into change of base formula?
Oh, isn't it E or something?
That's for Ella.
That's for Ellen.
Oh,
What do you put over what? You have to set up a fraction and you have to plug it in your calculator and solve. Not 4 over 11. You always put the large one over the small one, but you say log 11 over log 4. That's what x equals. So what is x congruent to? Somebody tell me.
1.7.
1.72.
Oh, yeah, the big number goes in.
Okay, that's how you're solving. Now, if you were to check this, right, I would put 1.72 into 4 to the x power. So 4 to the 1 point. My calculator needs to be turned on in order to look. 4 to the 1.72 gives me like 10.85, so we rounded, it's okay, not a big deal. But that's how you can check, okay? So when the base is not the same and you can't get it to the same thing, you have to use logarithmic function. Now, if it was e, I would have to use natural log, okay? If it said e to the x equals 11, I have to use natural log to cancel out the e. Here I use log. Now, and you're focusing on whatever side has the exponential power of x or the missing thing in the exponential power, okay? And then eventually you're gonna have to use change of base to solve. Okay, word problem. So, it says that an important application of exponential equations is Newton's law of cooling. This law states that for a cooling substance with initial temperature of T sub 0, the temperature T after T minutes can be modeled by T equals T sub 0 minus T sub R times e to the negative RT plus T sub R. What's this portion of the equation remind you of?
Is that like the interest rate?
Yeah, the interest, good. Okay, so it relates to that. Where T sub R is the surrounding temperature, R is the substance cooling rate. You are driving on a hot day when your car overheats and stops running. It overheats at 280 degrees Fahrenheit. And can be driven again at 230 degrees Fahrenheit. If R equals, I think it's negative 0.00, oh no, it's just 0.0048, okay? And it is 80 degrees outside. How long in minutes do you have to wait so you, until you continue driving? How do I set that up? You have every piece of information you need. And you don't have extra. So what is your T? What is your, the temperature that you need it to go to when you're driving?
230.
230. Okay. What is your initial temperature?
280.
Okay. What is your surrounding temperature? What? 80. And then times E. My R is 0.0048, so negative 0.0048. My T is what we're trying to find, yes, the time. And my other TR would be the same as this. How would you solve from here?
I would do parentheses first. So it's like Well, like,
No, think about where your missing variable is.
oh, okay,
Where is it?
at the top.
At the exponential function, right? So I wanna get everything away from my exponential function. Okay, so what do we wanna start by doing? Subtracting. What's 230 minus 80? Yep, 150 equals, and then inside this parentheses, I would have 200, right?
Mhm.
E to the negative 0.0048t. How do I get rid of 200? What's 150 divided by 200? 0.75. 0.75 equals e to the negative 0.0048t. Now what do? How do you get rid of e? E is ln. So what do I have to do with that? If e is ln, what do I have to do with ln? ln e to the negative 0.0048t equals ln 0.75. Here it cancels. What's ln of 0.75? Negative 0.287 equals negative 0.0048t. So I divide by negative 0.0048, and what do you get t to come out to be?
59.
Okay, I think it's like 59 point something, right? So they rounded up to 60 minutes.
Oh my god.
So it's gonna take you a whole hour to get back on the road.
Oh.
Just stay there.
Laura's like, no. Tyler said, last bell, he said, well, I just called AAA. I don't understand what I'm doing. Why am I figuring this out? I was like, okay. Okay, logarithmic equations, another rule, which we already talked about the opposite of this in the first rule that we looked at. Logarithmic equations are equations that involve logarithms of variable expressions. You can use the following property to solve some types of logarithmic equations. If b, x, and y are positive numbers with b not equaling 1, then log base b of x equals log base b of y means I can drop the logs and x equals y. Okay, so log base 2 of x equals log base 2 of 7, that means x equals 7.
Oh, that's
Simple, okay? So we're going to solve logarithmic functions using these rules. Log base 5 of 4x minus 7 equals log base 5 of x plus 5. What do I
Drop the
do?
log.
yeah.
Drop the logs. Okay, boom, boom. So you get 4x minus 7 equals x plus 5. Now what? Subtract x, add 7, right? 12 equals 3x, so x is going to equal. Now, you can check it by doing this. I'm going to plug 4 back into both sides. Log base 5 of 4 times 4 minus 7 equals log base 5 of 4 plus 5. What's 4 times 4?
16 minus 7 equals
9, and then 4 plus 5 is 9. Okay, same thing. So checks out. Now, what about this? What happens when there's only a log on one side? What happens when there's only a log on one side?
Should you
How can you get rid of a log?
buy
one more.
We did it earlier in this chapter.
E? No.
This isn't natural log, but if it was natural log, I'd use E.
So
What's my base on this log?
4.
4. What? Kind of, yes, Anna. I'm gonna take 4 and I'm gonna raise the power to all of this. So I'm gonna say 4 to the power of log base 4, 5x minus 1. Now, because I added a 4 over here, I have to add it over here. And you're gonna say 4 cubed. So both of your bases should be 4. and you should have powers on both sides, okay? This cancels, giving you 5x minus 1 equals 64, right? 4 times 4 times 4. Okay. Add 1, 5x equals 65. So what does x equal? 13. And once again, I can plug that back in and double check, because what's 13 times 5?
65.
And 65 minus 1 is?
64.
And you have log 4 of 64 equals 3. So if I rearrange that and said 3 to the, or not 3 to the, if I rearrange it the right way and say 4 cubed equals 64, I am correct. Okay? So if it has an exponent, you're using log or natural log. If it has log or natural log, you're using exponents, vice versa. Okay, this one is about checking for extraneous solutions. Okay, remember how on our last test, when you got 2 answers, you had to plug them back in and check because sometimes they're not both correct? Same thing happens with logarithmic functions. This is going to take us a while to work through, okay? The domain of logarithmic functions generally does not include all real numbers. Be sure to check for extraneous solutions of logarithmic equations. You can do this algebraically or graphically. We can't do it graphically because we don't have graphing calculators. So we're going to do it algebraically. Okay. So they want to know what are the solutions or solution of 2x plus log 2x plus log x minus 5 equals 2. First, what do you think I need to do to that equation? Can I solve it like that yet?
You could just plug it in. That's not gonna teach you anything.
Right, we need to know how to work it out right now. Okay, what do you know when you see this? What do we know when we see this right here? With that plus sign. What? No, not subtract. You multiply, right? I need to condense this side of the formula first, like we did last night in our homework. I need to condense this, okay? So if I'm condensing this, it's log 2x, right, times x minus 5. Because when there's a plus, I'm multiplying those portions together. Equals 2. Okay, so I've got to condense my side first. Okay, from there, what do you think I need to do? Nope, not a 2. What's my base of this log? If there's never a number there, what's your base?
1.
No. No.
Oh,
10.
yes.
Okay.
10. So this has a log, which means I'm going to take 10 and I'm going to put the log up in the power spot. Okay? So 10 to the log of 2x x minus 5 equals 10 squared, remember? Okay, this cancels, giving me 2x times x minus 5 equals 100. Now, what do I have to do from there?
Multiply again.
What do you mean multiply again?
You multiply 2x.
We didn't ever multiply first, but yes, I'm gonna distribute. 2x squared minus 10x, and I'm gonna just subtract this 100 over in the same time, because I want everything set to 0. What can I do from here?
Oh, what are those things called?
Mhm.
Group book.
Yeah, like, factor.
Yeah.
What can I take out of all that?
Oh my gosh.
Oh, yes, every chapter we've learned is coming together. Isn't that exciting? Okay, what can I take out of that? A 2. And you're left with x squared minus 5x minus 50 equals 0. Okay, what multiplies to give me negative 50 and adds to give me negative 5?
Negative 10 and 5.
Yep.
Sorry, that's smart as you.
So that means that x equals 10 or x equals negative 5. This is where you have to check for your solutions, which means I've got to plug these back into the original equation.
What happened to the 2?
What do you mean what happened to the 2? I don't need that 2 because I factored it out. Okay, if I would have left it in there and factored this way, it would still end up saying 10 or -5.
Well, we know it's not D.
You don't know that for sure, it could be both answers.
How? Because that's a -5.
Oh, okay, sorry. Yes, you're right. You know it's not D and you know it's not B.
What's that?
Right.
Okay,
It literally felt.
so it's A or it's C. Now, what we're gonna do is we're gonna take 10, we're gonna plug it into this equation. We're gonna take 5, we're gonna plug it into this equation. I suggest plugging it into the condensed form, it makes it easier, okay? So I'm gonna say log 2 times 10 times 10 minus 5 equals 2. What's 2 times 10? 20, and 20 times 5 is? 20 times 5? So you get log 100. What does log 100 equal?
15.05.
2.
Log 100 equals 2. So 2 equals 2. So we know that 10 is a solution. Okay, now we have to plug -5 in. Log 2 times -5, -5, oops, if I could write, that would help. -5 minus 5 equals 2. Okay, 2 times -5, -10, right? -10 times -10. Okay, so what's log?
Oh.
2.
What are you doing, my crazy girl? You're dropping things? Wait a second, that doesn't seem right, does it?
Wait, no, you're on the part of me now. Can I see that?
Oh, that's right.
Wait, for real?
-10 times negative.
Yeah, you sometimes -10 is.
No.
It doesn't work out right.
Don't talk to me.
If you do this, let me do something else for you. If you do it this way, log of 2 times -5 plus log of 2, no, what was it? Of -5 minus 5. Then you get log of -10, right? And you get log of -10. Yes, okay. This is what you have to do. You do have to plug back into the original equation no matter what. Because log of -10, press log of -10 in your calculator.
Then I probably say syntax.
Error.
Yes, okay. So you have to plug back into the original. Because log of -10 is not possible, so -5 is not a possible solution. In fact, I can never have a negative log. Okay? So it has to be plugged back in to this equation right here. Into the original equation. Okay? So my only answer is,
So is the first one still right?
yeah, the first one's still right, because it will come out positive no matter what. Because 2 times 10 is 20, 10 minus 5 is 5. It's gonna come out the same way still. Okay? That's what you're working on your homework tonight. Logarithmic functions.
This is not good.